The VFX topic I researched about is Matchmove and tracking. So matchmoving is a technique that allows the insertion of computer graphics into live action footage. The footage took in real life with its correct position, scale, orientation, and motion that relative to the photographed objects in the shot. So I would say matchmoving is definitely the foundation of pretty much all the VFX. So all the VFX shots that I think most of them required those kind of matchmoving in the beginning. If I want to put a 3D model into footage I took in real life, which I will do later, the first thing I will consider to do is matchmoving and a bit of camera tracking. Matchmoving sometimes referred to as motion tracking or camera solving. It is related to rotoscoping and photogrammetry as their theory. It is primarily used to track the movement of a camera through a shot. So an identical virtual camera move can be reproduced in a 3D animation program, which I will show later in Nuke. When new animated elements are composed back into the original live action shot, so they will appear in a perfectly matched perspective and therefore appear seamless in that live action shot. It is now an established visual effects tool, and it can also be used in live television broadcasts, such as the Olympic Games. When the swimmers are swimming their dedicated lanes, we often see the broadcasters, they put a dedicated banner on each swimmer's lane to show their names, nationality, or any data related to the match. Also in the United States, when the TV broadcasters broadcast the American football, you can usually see a yellow down line, but it's virtual yellow down line to the audience. For police chases, when they film the police chase from above on their helicopters, you can also see the virtual street names, any data related to the traffic, nearby parks, names of the buildings. Also at the same time, all these examples are matchmoving in the TV industry. Nowadays it became mostly real time, so it provides a better experience to the audience. The history of matchmoving. The earliest matchmoving can be found by, it was developed by the US Department of Defense for their guided missiles in as early as 1985. Later on, Industrial Light and Magic developed their first menu to the matchmoving tool called MM2 and successfully implemented in the movie Death Becomes Her. And of course, this movie got a lot of nominations for their VFX, so I'll say this is sort of like a first successful implementation of matchmoving. However, MM2 is not a fully automated program, meaning that Matchmove artists have to change the object positions manually for their each keyframes. In 1992, the earliest Matchmove system, called Flame, was published on the National Association of Broadcasters, also known as the NAB show, and opened the new era of matchmoving and camera tracking. But still, the functionality of Flame at that time was still limited due to the computer algorithm and calculation capacities. There are few problems matchmoving softwares was facing in the last 40 years of development. The major one is called the distortion, usually happened on the edge of the frame. That will give the software an incorrect locator. Other issues such as the anamorphic lenses when the focus has been changed. Also the fisheye lenses such as GoPro will have issues of distortion on the edge. When it comes to the actual filming, we're trying to avoid motion blur and occlude, which is obstructions in front of the screens, to ensure we get the best outcome out of the automated match-moving softwares. And that is all for today's introduction to match-moving. The next part of the video, I'll be showing you how to do the match-moving on the Nuke and how to import it to Maya. And also in Maya, how do we put a virtual 3D object into the real footage I just took outside of my house. The first thing we're going to do is open the Nuke software and import our in real life footage by pressing R. After that, we can drag the raw footage to the viewer, and the video, as you can see, the video will appear on the preview. The video format of this assessment is 1080p, which means the Nuke we can change the video resolution from the original default setting 4K to 1080p Full HD. In order to do this, just go to the right side panel. In format, there are system presets for different formats from 720p to 4K. And the next step we're going to do is go directly to camera tracking. In order to do this, just press tab and input camera tracking, and you will get a camera tracker box with a source and output. Simply connect the source to the raw footage and output to the viewer. The next thing we're going to do is to go to the first frame of the raw footage and press track. Then we will have to wait a couple of minutes. After the completion of the tracking process, we can just press solve. After that, we can just select a couple of locators on the ground by pressing shift at the same time. So once we select those dots on the ground, we can then right click it, choose ground plane, and then select to the ground. That simply means those dots are the plane, which it is the ground of the scene we're going to create later. And then we can press tab, and here you can see the Nuke give us the scene just created, and this is a 3D view. So to change between this tab and the previous raw footage, just simply press tab. Once we've done both tracking and solving, the next thing we can do is go to the auto trackers and delete rejected. That means we can delete those tracking points that is not really accurate compared to the rest of the tracking points. Next, we can go back to the camera trackers and change the export from the original camera to scene, and then press create. Nuke will then give us a preset of all the scene settings that we need. Then press tab and insert scanline renders to render this kind of 3D scene. So then we can connect these skyline render to the scene. In order to do that, just simply connect the camera to the camera and then the background as the scene. Then we connect the scene to the camera. And then finally, we connect the viewer to the render. And here you can see the gray-white the squares replacing the tracking points on our raw footage. And now we can finally export our tracking data using Bright Geo. So just press tab and create a Bright Geo, connect it to the scene we just created, and then if we connect the right geo to our viewer, then we can see the 3D camera and the tracking scene we created from the in real life footage. To export those data, just go to the right side of the panel and collect files. Execute it to the location we want it to be, which I'll put it on my desktop. But before doing that, since we are going to use this file in Maya, then I will put .fbx at the end of the file's name. After all of that, we are done with the nuke, and now we're jumping to Autodesk Maya for the rest of our tutorial. Well, however, since Maya doesn't allow me to successfully input all my image sequence, so I can't do anything after that step. If I decided to continue on nuke, so now we are selecting a couple of locators in nuke, and just to make sure those what I'm trying to do is to put a car in this footage, so it's got to be on the ground. So select a couple of locators on the ground, then right click it and select create cards, and here you can see we have a card that is assigned to those locators right here. From here we can do some adjustments on such as free transform on the right side panel, and now I'm going to create a new checkerboard and overlays the card we just created and link it back to the scene, and now we can see the card with the checkerboard overlays on top of it appears in the video that is attached to the locators we selected previously. Here you can see the checkerboard stays exactly where it should be, even though the camera angle is moving. Next, since we are going to put a virtual low poly car, the model of the car in this footage, then we're going to replace the card we have now by using right geo. After we selected the files we wanted to input, which is here, the card is shown in the scene, and same as the previous card settings, we can also do like transform or rotations on the right side panel. And now I have reduced the size of the 3D model of this car here, followed by some minor adjustments just to trying to perfectly align this car on the surface of the road. The operation of the 3D model in Nuke is actually pretty similar to Maya. Basically just all the rotations, vertex coordinates, just trying to, and all the transform sizes, or just to, everything is just to put this 3D model at the right place. After all that adjustments, now we can see the car is at the place where I want it to be. Now we're just going to simply press tab and then read a image, which is the UV map for this 3D model. It's pretty easy. Just drag the just let the right geo to read this UV map, and the car with the correct textures will be shown in the preview. And the preview definitely gives us an indication whether it is the tracking is working or it's not. I'm pretty satisfied with the outcome right now. Although you can see due to the I think it's a UV mapping problem, the textures applied on the ground of the car model, which normally shouldn't be there, but I haven't found a solution to solve that problem. I'm guessing if I just get a better 3D model, the problem will be solved. Lastly, we're going to export footage from Nuke. It is simple as just pressing a tab again, and then type right, connect the right to the render, then we will get the rendering panel on the right hand side. Choose the format I want, which is today I'm going to do the MOV file, so therefore I have to rename the file with .mov at the end. And also we need to choose the decoder, which is here I'm doing H.264. After all the settings has been done here, it's only the matter of time when it comes to rendering, and then we will get to see the final outcome. I'll consider this is a provisional sort of video showing how it works. It doesn't look quite well at the end, but if I spend a little bit more effort creating my own 3D model and own 3D mapping, the problem won't be that obvious here. But anyway, that will be the end of the tutorial here, and I hope you enjoyed it. Thank you.